Perfect. So yeah, thank you everyone for coming. We're super excited to be here to talk about this amazing and very interesting and challenging topic. My name is Andres Pereira, and I'll be moderating this session. But first of all, we wanted to mention a few housekeeping items. The first one being that this session is a bit longer than usual. It's going to be about 30 minutes of presentation plus 10 to 15 minutes of Q&A. And so please remember to write down your questions in the questions box on the control panel, and we will address the questions at the end. And we will make the presentation available as a PDF document. I think that it's already there, or if not, it's going to be available at the end of the session. So you can use it as you want. Having said that, we're just going to start. Perfect. So as I mentioned, and as you can see on your screens, we have Miguel Fagalde here, a project manager that's part of the power and energy team in Chile that has been involved in many hydrogen projects in Chile. Pablo Guerrera, a project coordinator from our southernmost office in the world in Puerto Montt. He's part of the Earth and Environment team in WSP Chile, and myself, I'm the Future Ready lead at WSP in Chile and Argentina, and as well as a project coordinator in the ESG and sustainability team. And we would like to go on to the agenda. So first of all, we're going to have a brief introduction. We're going to present a tiny bit about what our company is, how it looks like in Chile, the main projects, the main things, right? And then we're going to go and introduce the topic, hydrogen, to then go on a bit deeper with Miguel, who's going to speak about hydrogen and mega projects and some of the current challenges, being the main ones, technical or technological, regulatory, the market, environmental, and social. And then we're going to show you a way forward, our way forward, to finish off with the Q&A part of the session, right? But so first, WSP in Chile and Argentina. So we have over 1,400 colleagues in 5 offices with over $140 million in net revenue as of 2023. We've been involved in several, many very important projects in Chile. An example of this is the retrofitting of a major football stadium or soccer stadium. We've been involved in the construction of several metro lines in Chile, and our core business, not the only one, but a very, very strong one, is definitely mining. And we have also a lot of projects. Where you will find us, as I mentioned, we serve a wide range of consulting design services, from planning to commissioning support, in the sectors of infrastructure, environmental services, water, mining, industry, ESG advisory, transport, and power and energy. That's highlighted, of course, because it's the one that's the most relevant to today, right? But having said that, whenever we think about power and energy, the first thing that comes to mind is, of course, the energy metrics, or the composition of what gives us the energy that we need at industrial plants, at home, and so on and so forth, right? And when we look at it, what we had in 1990, and we compare it with what we have now in 2023 and the projections, we see that the conditions are very different. The composition of this is very, very different, right? And across all scenarios, the first one being on the left-hand side, the scenario where governments have implemented policies towards net zero or to lower the emissions, right? The second one is the announced public policies, right? And the third one is the one that we need to follow. the one that leads us effectively to net zero, right? But the thing is, when we look at the gap between what we're doing right now, the implemented policies, and what we need to do to limit global warming to 2 or 1.5%, so to achieve net zero, we usually talk about only power and energy, as in the electricity that comes out of our power plants, right? But the thing is, we're only addressing 20.7 out of 56.8 gigatons of CO2 equivalent, right? Equivalent CO2. So it's not only about producing the energy and the electricity in and of itself, but also the energy carriers that we need to produce to put that energy, clean energy, into our motors, into our industries, and so on and so forth, right? And that's where electric vehicles and batteries, but in particular hydrogen, which is the topic of today's session, comes into play, right? A key player. And with that introduction, I'll leave you with Miguel, who's going to take us through the hydrogen revolution. So,
thank you very much, Andres. It's an honor to be here today. Let's go to start defining the green hydrogen revolution. The market gained significant relevance worldwide, generating many projects and development to produce energy to help or avoid or reduce the global warming. As we can see, we can see in the graph, in the project in the world is announced too many projects, up to or more than 8,000 projects. And if you can see, the red one is early stage. In the orange, it is the facility stage. On blue, in the final investment decision stage or construction. And in the green are in the operation. Okay. And in the end, the size of the square is mean the different capacities each project. Sorry. In this presentation, we will focus in the project announced in the South America. The place is in Magallanes. Okay, in the bottom of the Chile. Yeah. Please, the next, please, Andres. So we can start knowing, we have to know what is mean mega projects. Science from the Project Manager Institute and Inter-American Development Bank, the mega projects is a project with extensive duration budget, multi-stakeholder, can create substance employed, have elevated risk, sometimes can do institution strength, and have very high technology, legal, and environmental challenges. Today, we will define the mega projects less than more than 1 gigawatt. Okay, the mega projects, we have to know, or we have to remember, the mega projects potentially contribute the economic growth and become of a vital part of the community, the economy. Pardon. The next one. Okay, in Magallanes is in the bottom of the South America. This place is very good for the wind energy. Have the factor capacity over 60%, and the usual for that is around the 20 or 40%. So it's almost the double or more capacity with the different countries. So the difficult for that is a stronger wind of there, have the heavy snowfall, in the winter have very short days, and it's a remote area. We don't have a big city near to this place. Okay, the next one, please. In Magallanes, we have maybe we have 8 or 10 projects is announced. Every project have a range to 1.4 or 5.8 gigawatts. With this project, we can have 200 or 800 wind turbines. The capacity for the electrolyzer is 1 gigawatt or 5 gigawatt, and the production is around the 60 or 300 for produce ammonia. Okay, this place is 60,000 hectares. Is similar to the site of Hamburgo, Toronto, Chicago. It's the same area you need for do this project. So it's huge in dimension. Okay, the next one, please. Now, if we can see, we can thinking about the scope of these projects. The energy supply is the high one. This is the bigger area what is needed, and this place need battery or storage, energy storage, transmission. In the industrial process, we have the hydrogen production, ammonia production, the nitrogen capture, and sometimes you can have in display the storage, or sometimes all the storage is in the port. In the port, you have the desalination plant for the export and import element from the ship. Okay, this is a very important point. You have to remember the eolic system sometimes can have 100 meters, so it's difficult to move for some place. Okay, in the last one is auxiliary facilities. This is very important. This is everything what you need for have the construction. For example, substation, camp, water treatment plant. For the construction, or for you need concrete, gravel, workshop, and the other stuff is security, fuel station, road, but amongst other, and depend of the constructability strategy. Okay, the next one, please. Here we can see the area. For example, this is the process plan in the left. In the right, in the top, you can see the wind turbines, and in the bottom is a port area with the desalination and ammonia storage. Okay, this is for understand how big is the process plant. But the bigger one is the aeolic farm. Okay, the next one, please. Okay, the challenger. This is the point, the main point. We will talking about the electrolyzer technology. The H is EI and advancing regulation. The scale, constructability and integration. The market, the important one, and environmental and social challenges. Okay, the next one, please. So we will have a focus in the electrolyzer system. The electrolyzer system doesn't exceed the 9 level. We have some level for know which one is the development of the technology. If you can see the color, the blue one is the mature technology, but the electrolyzer is in night, like in the night. is a market up to date, but anyway, is still in the development this technology. Okay, the next one, please. So the second one is the safety and regulation challenger. The hydrogen flame, you can see the flame. Is very have a risk from this gas, because the inflammability is between 4 and to 75%. The natural gas is 5 to 15. The gasoline is 1.4 and to 7.4. So the hydrogen is highly flammable gas, and if you can see, the fireman is take the same picture but with the thermograph camera, and you can see the flame, but within the camera, but in the top picture, you don't can see the flame. Okay, the next one, please. For that reason, it's very necessary to develop some standard in the world. Have some standard worldwide, but the local authority is needed add this in the system, and this is very slower because have governmental issues or manager some system for doing that. For that reason, the advance in regulation is very slow, and is slower than the market. Okay, the next one, please. So the last one, the other one is a scale, constructibility, and integration challenger. How you know, or how you can know this facilities is huge. Have all the specialists for doing that, for mechanical, power system, structural, architect. Everyone can do or have to work in this project or kind of project. And how it is the remote place, and you need a lot of people, maybe 400 or 4,000 or 8,000, depending on the constructibility strategy. You have to have in the place camp for all the people. You have to have the treatment water for that, all the construction facilities. But the problem is the world doesn't have the large experience. The bigger one, or the larger green hydrogen project, is in China. It's 260 megawatt with 150 megawatt in electrolyzer. This is the higher one, or the bigger one, and we are talking about the 3 or 4 gigawatt. It's almost 20 times this project, and this is difficult all the development for doing this kind of projects. The other challenge is the cost of the energy. For the inflation and the wars, the cost doesn't get down. As well, the electrolyzer manufacturing cost. This is the main factor for the price of the hydrogen. We have to develop it, enable infrastructure. We need capacity in the human capital, and this stuff is needed or produce the market uncertainly, and that produce the next one, please. produce the different what we expect in the 2020. We are thinking about the price it gone down from the $6 or $7 per kilogram, but doesn't go down. And we needed that because the fossil fuel range is between 1.2 and 2.4. This is the range. So if we want to buy some fuel, different fuel, green or blue, doesn't matter because the consumer have to pay that, and that is the cost. So if we want to buy this kind of gas, is needed be the competitive price. Okay, and we can see in the right one, the price is getting high. Now in California, it's almost $30 dollar per kilogram. So this produce for everything, the uncertainty and indecision on long-term buyer contractor, because we expect have 1.5, but the real price is no less than $10 per kilogram. Okay. Now we can pass to for Paulo. Please, Paulo.
Okay, Miguel, thank you. When we think about the challenge of the environmental area, we started with the what is the cost of the net zero. We all agree we need to migrate or change our type of energy, and because he have a lot of a huge problem with the emission of the green gases and the climate change. But what is the cause of that? What is the environmental and social cost of that transformation? We need to move at new energies, but what is the real cost with that transformation? The next one, please, Andres. If we think about the generation and transmission of the energy, in like Miguel say, in the Patagonia, we could be identify the source of renewable energy. It's the wind, and the wind it's have a lot of potential, but the size of the project it's so high, and they could be produce a different kind of impact of the wildlife and the different ecosystem of the Patagonia, of the unique ecosystem of the Patagonia. The other one, please. For the other hand, when you think about the industrial process, the ability of this disponibility of the fresh water or for the process, they have a lot of problem with the impact with the of the discharge of the wastewater with a highly concentrated sodium chloride. Maybe that could be impact of the ocean ecosystem and the different wildlife they could be identified. In some project, we could be identified some species of dolphins or different kind of mammals, and they are very singular and particular at the Patagonia. The next one, please, Andres. For the other hand, when we think about the construction of this kind of project, not just in the auxiliary facilities, it's not, if you think with the construction and of the entire process, the highly potential of the development of kind of project is in the Patagonia. And one of the particularly is the low population density. Just for example, in the town of San Gregorio, the resident is almost 1,000. For the construction for one of just one project, they could need almost 4,000 workers around. and it's a lot. They could be create huge impact at the service, the infrastructure of this little town, and for the other hand, the Patagonia is a very interesting and knowledge around the world and for unique value and the tourists, and that could be have a little problem with the landscape. If we try to understand and put it all these kind of different impact and the social and environmental way, we could be identified different scheme of certification of the green hydrogen. They try to put at the value of the a specific block of the all valuable chain, but we can compare of or for the different scheme of certification, and that could be make a little they create a complication of the certification of the green hydrogen, and maybe could be create a double counting in some occasion. The next one, please, Andres. Right now, if we talk about the reality in South America, we have different realities because the different countries try to create some regulatory framework, but not just in a collaborative way. Some countries like Chile and Argentina will be create a national strategy. From the other case, in another countries like Colombia or Ecuador, they create just a guideline, and Brazil have a national program. This framework, they need to work in a collaborative way. The next one, please, Andres. With this reality and this different kind of impact, we started to think what we could be moved forward. Yeah, and in this way, we thinking in 3 different opportunities. The next one, please, Andres. The first one is the holistic approach, each to their own, and the horizontal collaboration. Next one, please. If we think about the holistic approach, we have a lot of skills and capacities for the entire WSP company. We could be collaborated and create a coordinated action with the entire project. Started with the strategy advisor. We have the entire specialized environmental and engineering study, and we could be helped with the design and construction of the management service. The next one, please, Andres. This is just an example. We work in almost 100 existing projects with the capacity of 3 gigawatt or at least. And we have almost 300 professionals in 20 countries. We work in the development of the green hydrogen project. If we think about the challenge and the opportunity to developing those kind of energy, one of the most important thing we are identified to right now is all the projects try to create one operator could be develop all the entire valuable chain. But if we think the challenge that could be created at the environmental or the social or the technical area, it's a huge problem project, and we are very we think the right way to improve the development this kind of project is the integration of different operator or the different at the different block of the valuable chain. We know a lot of companies with a technical knowledge of the process, the different block of the process, they know their own certification scheme and their own regulation framework, and that could be a huge opportunity to development at the right way the different process of the entire production of the green hydrogen. The next one, please, Andres. Maybe that's it. One of the most important things, we are pretty sure there could be collaborated at the horizontal or the other horizontal collaboration, because you have a direct contact with a different stakeholder and the knowledge about the equipment, process, and advanced technology. We could be helped at the collaborative work with the authorities, the local authorities, and create some regulation. We try to say we could be helped at the development, not just in the public and area. We could be helped in both areas, the public and the private area. The next one, please, Andres. The key takeaways. If we think about the principal, the conclusion of the webinar, we could be say the hydrogen is the key achieved to the net zero target and commitment. Next one, the hydrogen mega project face complex challenge, including the technical, regulatory, market, and social environmental. The last one is a holistic collaboration, a specialized approach is needed to overcome the current difficulties and realize the hydrogen agenda. The next one, please. That's it. That's it. All the presentation about the this webinar, and that's it. All we could be to say.
Perfect. Thank you, Pablo. Thank you, Miguel. So just to remind you guys, please log your questions in the question box on the control panel. We will address the questions, and this presentation will be available. So you can have all the images and all the information that we're presenting right now. And to start this Q&A session, or part of the session, I have a few questions that I would like you guys to address. Maybe I can answer some of those, but I think most of them might direct it at you guys. So the first one being, what are common hurdles to approving hydrogen projects during or in the context of environmental assessments?
Okay, thanks, Andre. That's a very good question. In our experience, we could be see the environmental assessment. We could be identified three different opportunities. First one is the collaboration of the with the authority, because they have improved his knowledge and for the assessment of that kind of project. The next one maybe could be we don't know we don't have enough knowledge about the environmental impact and the ecosystem and the wildlife, and that it's a huge challenge to create new knowledge on and the right management of that kind of impact. And that is and the social impact. One of the most important we will see is the impact of the lifestyle of the population, where the Patagonia have almost one of the lowest population density, and the construction for one of these projects could be create as a huge pressure of the entire infrastructure and the system of that little town in the south of South America.
Perfect. Thank you, Pablo. The second question is for Miguel. We have here a question that goes, is there any work going on for hydrogen geostorage? So hydrogen stored in underground parts of the projects?
The storage in underground, actually WSP is working in some projects in Utah Provo. It's a bigger project in the world. This is possible. The engineering for that and the perfectibility is developing at the moment. So yeah, it's a very good option for have this storage, but sometimes the question is the price, okay? But it's a very good opportunity to have this kind of storage.
Perfect. Thank you, Miguel. The third question goes to Pablo, and it's a very interesting one because we've talked about the net zero agenda. That's a mankind sort of goal, right? But what are the projects benefits to the people living around those areas? Is there any benefits that you would like to mention?
That's a very good question because in all the project we will work, we could be identified a huge potential of the contribution of the population, yeah, of the people at the territory. We will see one of the highly potential development is the creation of new is try to help the community to improve for own educational level, yeah, and try to improve that the technical resource. Maybe for the other hand, they must be contribute. All the project could be contribute with the public infrastructure, like a hospital or maybe in a school. That could be a huge impact for the community because they are live so in areas with a very difficult access. That could be a lot of help for that kind of community and the little town.
Perfect. Thank you, Pablo. The fourth question is the green hydrogen production wastes a lot of energy through heat, approximately 40%. Are there other options? Miguel, I think that this is directed at you.
Yes. Yeah, this is, thank you. It's very good question. We have some gap in efficiency energy from the process. In the process, how he said is waste a lot energy, and for that we have some opportunities like for do something with this waste energy, but now the focus is the development the actual situation or this challenger. So maybe in the future we will have more news about that. Some gap is there. It's opportunity for everyone, maybe for the engineering system as well. The electrolyzer SOEC is called. SOEC is the last technology or the final one. Maybe it's ready for to the same level than PEM and alkaline in few years more. But for example, the ammonia production maybe it's the best way for try to get more energy from the process. So yes, have opportunity is we can do something about that. This available energy we can use in the same process. So yeah, we can do something, but it's the development at the moment.
Perfect. Thank you. I think we have questions. Time for 2 more questions. The next one I would like to answer. Is hydrogen a good alternative to batteries for cars? So, and correct me if I'm wrong, Miguel, because you gave me this analogy. But when we think about batteries and hydrogen, we need to think about like people doing endurance and Usain Bolt, right? So batteries are going to get you there faster, right? But they're going to allow you to travel a short amount of kilometers, right? Whereas hydrogen has a higher like energy potential, right? So it's designed for larger things. So hydrogen might not be key to individual, like personal cars, those hatchbacks, but on the other hand, it might be perfect for ships, and shipping is only increasing, right? Or the energy crisis that that the war in Europe unleashed, so to speak, right? So batteries, I think that complement hydrogen. They're not competitors, or at least we don't see it that way. And the last question that we're gonna answer is this one here, and this one I think it goes also to Miguel. Does the H2, so hydrogen production, work well with the intermittent power supply, or does it need a steady base power?
Yeah, this point is very relevant. The intermittence of the energy is from the renewable energy, so you can solve this problem, or this is the real life, for say something. But it's not a problem. The problem is for the hydrogen process is the ammonia process. So, for example, the final product, because the other process is for do the ammonia, you need the higher voltage, and this have the very high temperature and pressure. But when you don't have any hydrogen, the temperature is going down, and after, when you have to work with the more capacity, that is a problem for the process. So the intermittence is a problem for the storage, for how much you need for the autonomy. Okay, because the higher voltage can't stop. Maybe the ramp, the low ramp is 10% or 20%, depend of the manufacturing. But the problem for the intermittence means in final in the storage for the project, in the capex finally. Okay.
Perfect. Okay, fantastic. I think that we've reached the end of the session. I thank you, Pablo and Miguel, and of course Sharon has helped us organize this webinar so much. And thank you to each and every one of you for joining us. This has been a very interesting conversation, and we hope to hear from you guys. If you have any questions, do not hesitate to contact us. Miguel, Pablo, and I, and me, we'll be more than happy to have more conversations and interact and blah blah blah. So, without further ado, you can go back to working or go home. I don't know what time it is where you're connecting from. So, yep, that would be all. Thank you.